Find the equation of the plane that passes through the point 6, 1, negative 3 and contains the line with symmetric equations x over 3 equals y plus 4 equals z over 2. So the assumption here is that there exists a plane that contains a point, we'll call it P, and it has coordinates 6, negative 1, 3, and also contains a line, we'll call it L, and L is the line given in the problem. Now, reading the symmetric equations of a line, the line has a vector, has a direction that is a vector v, and it's 3, 1, 2. Since that exists in the plane, we have a vector on the plane and we have a point on the plane. But what is it that we actually need? We're trying to come up with the equation of a plane. We need the normal vector for the plane. In order to come up with the normal vector for the plane, working backwards, we need two vectors u and v so I can find their cross product. Well, we already have a vector v. We need a vector u. We have a point on the plane. If we had a second point on the plane, we could come up with u. So we need u cross v, for which we need u. For that, we need a point on the plane. And really, I mean, we need a second point on the plane, don't I? Once I have the second point on the plane, then I have the vector u. Then I can form the cross product and come up with the vector n. That's our game plan. The second point is actually going to come from the equation of the line. And remember that the symmetric equations of a line are x minus x naught over a equals y minus y naught over b equals z minus z naught over c. And so we know by looking at the equation of the line, or the symmetric equations of the line that we were given, that the point 0, negative 4, 0 is on the plane. Well, it's on the line, which means it's also on the plane. I'm going to put a point on the line that will represent 0, negative 4, 0. And the vector that we're after, u, is going to be the one that goes from the point 0, negative 4, 0 to the point P, which is 6, negative 1, 3. That'll be our vector u. And remember, in order to come up with the components of u, we're going to subtract the coordinates of P minus the coordinates of 0, negative 4, 0. So we get 6 minus 0, negative 1 minus negative 4, 3 minus 0. So our vector u is equal to 6, 3, 3. We only need the vector u because we're going to form a cross product u cross v. And in order to get a vector that is orthogonal to both u and v. And here it is, so that we get a normal vector. We can use a vector that is parallel to u. My point here is I'm actually going to use the vector 2, 1, 1. I've divided all the components by 3. 2, 1, 1 is a vector that is parallel to 6, 3, 3, and I'm going to get smaller numbers by using this. Well, our vector u cross v is going to be developed by u. What I'd like for you to do is go ahead and finish off the work for this problem. For our cross product, we get 1, negative 1, negative 1. Using those as coefficients in the equation of our plane, we get, and the point 6, negative 1, 3. We get 1 times the quantity of x minus 6 minus 1 times the quantity of y plus 1 minus 1 times the quantity of z minus 3. The equation of our plane is x minus y minus z equals 4. Next up, we're going to find where the line through negative 3, 1, 0 and negative 1, 5, 6 intersects the plane 2x plus y minus z equals negative 2. The idea here is that we have a plane and a line. The line intersects the plane. We just want to find the point where that occurs. We're given 2 points on the line. Let's say they're here and here. So we're not necessarily given the point of intersection. It'd be kind of weird if we were. Now, not really knowing where we're going to go with this, we have 2 points and we can come up with the equation of a line. What form of equation of a line would be useful? I'd like for you to pause the video here and come up with the equation of the line that goes through the 2 points. using the coordinates of negative 1, 5, 6 and subtracting the coordinates negative 3, 1, 0, we end up with v is equal to 2, 4, 6. I went that way so that I'd have positive numbers if possible. Now 2, 4, 6 is a direction for the line. I'm actually going to use 1, 2, 3 just because it's parallel and those numbers are smaller. And then I just randomly picked the point negative 3, 1, 0. You could have used the other point as well. The parametric equations of the line are x equals negative 3 plus t, y equals 1 plus 2t, and z equals 3t. I went with parametric because I kind of know where we're going to go with this. If we had symmetric equations, they would be x plus 3 is equal to y minus 1 over 2 is equal to z over 3. But those are not as useful in this context. See, we have the equation of a plane here. And if I had a value that I could put in place of x, y, and z, then I'd be able to do something with the equation of the plane. Instead of values, I have expressions. In place of x, I'm going to put negative 3 plus t. In place of y, I'm going to put 1 plus 2t. And in place of z, I'm going to put 3t. In so doing, I'm going to end up with an equation that has only t. If I solve for t, then I'll be well on my way. Making those substitutions, I get 2 times the quantity of negative 3 plus t plus 1 plus 2t minus 3t equals negative 2. Collecting like terms and solving for t gives us that t is equal to 3. And if we substitute t equals 3 in the expressions for x, y, and z, then we end up with x, y, z is equal to 0 for x, 7 for y, and 9 for z. That answers the question. Now let's see what we've done here. Because we have these expressions for x, y, and z that include t, it's easy to see what point we have when t is equal to 0. And when t is equal to 0, we have the point negative 3, 1, 0. So let's say that this point here I've identified as that. If we let t equal 2, then we get the point negative 1, 5, 6, and we'll have the 2 points that were referenced in the problem here. Let's call this where t is equal to 2. And what we found was that when t is 3, we have a point of intersection between the line and the plane. That's the point 0, 7, 9, but according to our picture here, I could say this point here is where t is equal to 3. So that's just a visual to establish what it is that we've done.